Assalamualaikum. On this video, I want to introduce the linear power supply and the circuit inside it. This is the circuit schematic inside the linear power supply. The main objective designing this circuit is to convert the AC voltage to DC voltage. The circuit system can be distributed into three parts: rectifier, filter, and voltage regulator. Each part has its own specific electronic component in order to function. For the example, rectifier, we will use four regular diode, and for the filter, we will use a capacitor, and for the voltage regulator, we will use the Zener diode. Let's do the demonstration of the schematic circuit using the TikiCAD. This circuit gets source of the energy from the power supply. The power supply has been set to 10 volt and the frequency is 50 Hz. And the sign for the function type. All of the oscilloscope has been set by 5 millisecond per division. So let's try to simulate this circuit. On the left oscilloscope over here, it shows a sinusoidal graph. It happened because of the voltage is directly from the power supply, and the power supply is a AC voltage. Next to the oscilloscope 1 is the oscilloscope 6, and it shows a pulsating DC voltage. This happened because during the positive cycle, diode 1 and diode 3 are forward biased and it allows the current to flow to the circuit. During the negative cycle, diode 2 and diode 4 are forward biased and it allows the current to flow to the circuit. The direction of the current that enter to the load is same during the positive cycle. The output voltage is still same, even is during negative cycle. Since the full wave bridge rectifier able to rectify both the positive and negative cycle AC input, full wave bridge rectifier is more efficient compared to the center tap rectifier. Next to the oscilloscope 6 is the oscilloscope that display the electrical signal on the capacitor. So it should be over here. The capacitor reduce the variation in the rectifier voltage. The small amount of fluctuation here is the ripple. During the positive cycle, the diode 1 and diode 3 is a forward bias. The capacitor start charging gradually to the peak value. During the negative cycle, the diode 2 and diode 4 is a reverse bias. The capacitor start discharging and the current flow through the load here. During the next positive cycle, the capacitor start charging again. This is how the process the capacitor change the graph on the oscilloscope from the pulsating DC voltage to the ripple peak-to-peak voltage. This oscilloscope here is the oscilloscope that display the electrical signal across the load and it's after the Zener diode here. We will observe a horizontal line on the last oscilloscope. The main purpose of the Zener diode is to maintain constant voltage DC even there are changing in the output resistance or the input signal. That is the reason the graph is changing from the ripple peak-to-peak voltage to a horizontal line here. After all of the current flow in the circuit, we will consider that the, the circuit succeed convert AC voltage to a DC voltage.